Hello, today we are doing a question from Hydrostat. Actually, it's not only from Hydrostat, actually it's a combination of heat and hydrostat. So these type of question actually we can see in MCQ paper between 25 to 30, 35 actually. It's a bit of a difficult type of questions. So give it a try and let's see how we do the question. Alright, I hope you have tried the question now, and if you could do it, that's great, right? So let's give it a try, or just follow my method and you will see something new, of course. Right, so first thing, so they are asking us to find the temperature difference, right? Delta theta value, right? So here in the first data they are telling us the current reaction, right? The reaction here, the R value, the reaction value is half of the weight, so it's basically mg by 2, right? So that means, so here you can, if you consider the upward forces and downward forces, what actually happens is R plus mg, that is equal to, yes, actually not R plus mg, R plus u upthrust, that is equal to mg. So they are telling our reaction force is mg by 2. That means here the upthrust is equal to mg by 2, right? So this is how we get the upthrust. V, volume of the container, rho W, density of the liquid, into G, that is equal to mg by 2, right? This is our very first equation. So we need to consider another situation where temperature difference occurs, right? So we are moving into that part now, right? So what actually happens is when the temperature increases, this volume, this particular volume will increase, and there will be obviously a change in density for sure. These two will occur, right? So moving into the second part now, let's increase the temperature by delta theta now. That is the increment. Alright. So what actually happens here, the volume of this block will increase. So V, it will become V into 1 plus, I hope you know the equations, 3 alpha delta theta, right? So linear expansion is given as alpha, so volume expansion 1 plus 3 alpha delta theta. This is the final volume, say V1 of the block after being increased, the temperature increment, right? Then what actually happens to the density? Density, what actually, let's say density becomes rho 1. So the final upthrust, let's see, the second situation they are telling V1, the final volume of block, into rho 1, density of liquid, and G, right, that is equal to mg. So they are not directly telling it. What they are telling is, they are telling reaction becomes 0. So from this equation we can tell, yes, if reaction becomes 0, upthrust must be equal to mg. So we are taking upthrust V rho 1 g, that is equal to the weight, right? Then what we are doing here, so V rho 1 g equals mg, right? Let's write the value of V1, that is, actually we get it from here. So V1 plus 3 alpha delta theta, that is into rho 1 g equals to mg. That is our second equation, right? So let's write down both equations together. So we have V rho 1 g equals mg by 2, first equation. So what we have to do is we have to divide second one by first one, right? So see what we are getting now, right? V and V cancel off. So what I am getting is 1 plus 3 alpha delta theta over rho 1 divided by rho W equals mg cancel off, and it becomes 2. So finally I am getting, right, move on, 1 plus 3 alpha delta theta equals rho 1 equals 2 rho w, right? So now here from this equation we are connecting density and heat change. Let's connect density and the temperature change, right? So our rho 1 value equals 2 rho w 1 plus 3 alpha delta theta, right? So this is what we got from here. So then we have the final density and the connection between the initial density. So here we have to connect these two equations actually from the heat equation. So the variation of density with the increment of temperature. You should know this equation. So that is basically rho 1 is equal to rho naught 1 plus gamma delta theta. So this is actually from liquid increment, liquid expansion, right? So let's equalize these two. So here what I can write is 2 rho w 1 plus 3 alpha delta theta equals to rho naught, basically that is the initial density, that's rho w 1 plus gamma delta theta. Right, now we are moving into, we have to subject delta theta value, that is our final answer, right? Let's simplify it now. Hope you can see rho w cancel off. So I am doing cross multiplication, right? 2 plus 2 gamma delta theta equals to 1 plus 3 alpha delta theta, right? So what I am doing is I am bringing this here and this there. So 1 equals 3 alpha delta theta minus 2 gamma delta theta. Easy. Now I am subjecting delta theta value out of this. So 3 alpha minus 2 gamma delta theta, right? Take it out. Actually, if you have to have this mathematical ability to subject certain values from an equation, that is a must. So here delta theta, I hope you can see it here. Delta theta equals 1 divided by 3 alpha minus 2 gamma. So that is our temperature change. Students, if you could get the answer, actually that is great. That means you have certain level of mathematical skill, and of course you can connect the equations from heat to other set of questions, sort of equations. That is great. So remember that you have to have this ability to connect the other equation from other lessons actually. So interconnection between the lessons, you have to have this ability, and you have to master this skill for sure, right? So I have given you lots of questions actually from these type of methods. So basically what you have to do is you have to go through with those actually questions I have given you. So give it a try, and practice makes it permanent for sure. So give it a go. Yes.